Hello students, let us solve one more problem. So this is a function is given which is double exponential function. So if I draw this function, this is at t is equal to 0, this is 1, and as t goes to infinite, it becomes 0 and both sided. Now we need to calculate the Fourier transform of this function ft. So Fourier transform of ft. So we know the definition 1 upon root 2 pi minus infinite to infinite ft e power minus iota omega t dt. Now this will be 1 upon root 2 pi. So you can break the integration in two parts from minus infinite to 0. That means here t less than 0 part, the function is alpha t. So this become alpha minus iota omega t dt, and from 0 to infinity the function is e power minus alpha 2 for positive side. So this become e power minus alpha plus iota omega t dt. Now just integrate this function. So if I integrate this function, this will give me 1 upon root 2 pi. This will give me e power alpha minus iota omega t. Okay, this is alpha minus iota omega. The limit is minus infinite to 0, and then you have here e power minus alpha plus iota omega t, here minus alpha plus iota omega, alpha plus iota omega. Now just put the limit. You have a limit here minus pi to here is 0 to infinite. So let us solve this one. So if you put the limit, so my Fourier transform of ft will be 1 upon root 2 pi. If I put 0 here, alpha minus infinity becomes 0. So you have only 1 upon alpha minus iota omega. Okay. And then you have here t0 here. You put infinite here, this becomes 0. And you put minus minus become plus. So this becomes 1 upon alpha iota omega, because here minus is there. So I can put 0 first, and then infinity becomes 0, and 0 becomes this 1 upon alpha plus iota omega, and this gives me 1 upon root 2 pi. This will give me alpha square plus omega square. This will give me alpha plus iota omega, alpha minus iota omega. So your remaining will be 2 alpha. So this is my Fourier transform. Okay, Fourier transform is given by 1 upon root 2 pi 2 alpha alpha square omega square. And now this function, so we have already seen that if my function ut step function, how do we define? Step function is 1 when t is greater than 0, 0 when t is less than 0. Similarly, I can define u minus t. The u minus t is what? U minus t is function is 0 when t is greater than 0, and function is 1 when t is less than 0. So this function is like this. This value is 1 when t is positive, and this is ut. And if I plot u minus t, u minus t, that is like this. Okay. So this side it is 1. So now we have already seen my previous video that if I write, if I take Fourier transform of E alpha t ut is equal to 1 upon alpha plus iota omega. Of course, there is 2 root pi here. Similarly, if I take Fourier transform of E alpha t u minus t, that will give me 1 upon root 2 pi 1 upon alpha minus iota omega. Okay. So that means the given function, okay, whatever function is given ft to us. So ft is what? Basically ft is e minus alpha t when t is greater than 0, and e is alpha t when t is less than 0. This basically, this function is a combination of e minus alpha t ut and e alpha t. So what I'm writing, this function ft is basically your e minus alpha t when t is greater than 0 and e alpha t when t is less than 0. This function is basically sum of e minus alpha t ut plus e alpha t u minus t. This is ft. So this is the function of combination of this function, and we already seen this is 1 upon alpha plus iota omega, and this is 1 upon alpha minus iota omega, and 1 upon or root 2 pi, which is 2 alpha square plus omega square. Okay, I'll stop here. Thank you.